Good morning to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering, MLR Institute of Technology. In this video, we are going to discuss about the performance analysis of an algorithm. So, what is meant by performance analysis? How many types of performance analysis metrics are there? And we can understanding those two metrics with the help of the example. So, there are so many algorithms are there. For one problem, there is a multiple solutions are there. For one problem, there is a multiple solutions. S1, S2, S3 are the three solutions for P1 problem. But among all these problems, which solution is best, or which solution is fast, or which solution is takes less cost. So we are going to take all these metrics as a consideration. We need to measure the performance of these three solutions. How to measure the performance of an algorithm? There are two performance metrics are there. One is called as a time complexity, another one is a space complexity. These two are called as a performance metrics of an algorithm. These two are called as a performance metrics of an algorithm. So, for one problem, there are multiple solutions are exist. Among all the solutions, which solution is best? So, in terms of cost or in terms of time. So, for deciding whether it is a good or it is a bad, we need to calculate the time complexity and space complexity. That's why these two are called as a performance metrics of an algorithm. The first coming to the first metrics called time complexity. So, how to measure the time complexity? What is the definition of time complexity? The time complexity of an algorithm is so how much of time is taken by the algorithm to complete the given problem. To complete the given problem, how much of time is taken by the algorithm? That is called as a time complexity. For example, suppose the work is assigned to three persons, P1, P2, P3. So, the deadline is 5 days. Suppose the person 1 can complete it within 2 days, person 2 completed 4 days, person 3 takes 10 days. So, who is the best means simply we can say that P1 is the best because he completed with less number of days, That less number of days is nothing but a best. So, in this case of performance analysis also, we need to measure how much of time is taken by the algorithm for successful completion of the given statement. That is called as a time complexity. Second one is the space complexity. So, the space complexity means how much of amount of memory or it is a space, amount of memory or space, amount of space taken by the algorithm to complete its task. So, that is called as a space complexity. So, we are going to look at some examples how to calculate the time complexity and space complexity for the given programs or it is a problems. So, first consider the time complexity. So, we already discussed about the definition, how much of time is taken by the algorithm, that is called as a time complexity. One of the most used method in the time complexity is the frequency count. What is the frequency count? Means how many times the particular statement is executed. That is called as a frequency count. So, in the case of frequency count, we need to take the frequency of each statement and calculate what is the total time complexity. So, this time complexity is in the form of constant time. Suppose if it is taken as a, 2 times is repeated, we can take it as a constant time is big O of 1. Suppose the algorithm takes 2n. We are going to take the n is the time complexity, that is big O of n. It is a n square. Time complexity is big O of n square. So, that is a logarithmic time complexity, constant time complexity, square time complexity, or it is a big O of n cube time complexity. There is a different types of time complexity is there. So, this time complexity depends upon some constraints, or it is a the algorithm will be depends upon some parameters. The first parameter is first one is whether this program is running on the single processor or it is a multi-processor mission. In single processor, we can execute only one line at a time. After the completion of the entire program, then we'll go for the second program, or it is a second process. But in the case of multi-processor, we can execute three or more programs at a time. Multiple programs are running in a single system. So that is also one of the important factor for calculating the running time of an algorithm. Second one is whether it is a 32-bit mission or it is a 64-bit mission. So what is the speed of the processor? Whether it is running on 32-bit processor or it is a 64-bit processor. And also what is the speed of read and write? How much of time is taken for taking the input from the keyboard? How much of time is taken to display the data or it is the output on the screen? Next, the amount of time required by the algorithm depends upon the operators also. Arithmetic operators, logical operators, how much of time is taken for assignment operator, for return statement, and also input data. That means how many values you are taking from the keyboard. Whether you are taking single value, it takes only 1 unit of time. If it is a 3 values, 3 units of time. So that is also one of the important factor for measuring the time complexity. So the first one is whether it is running on single processor or multi-processor, 32-bit mission or 64-bit mission. How many values you are reading, what is the speed of read as well as write. Third one is how much of time is taken for arithmetic operators, logical operators and assignment operators. Then how many values we are reading from the keyboard. All these are the important parameters we need to consider. So for measuring the time complexity of an algorithm. One of the most important method is a frequency count. Let us look at some examples. So how to compute the time complexity? This is the given algorithm. That means frequency count means how much of time is taken by each statement. So in the case of algorithm message, this is the algorithm heading. Algorithm heading is never executed by the compiler. So this executed 0 times. This executed 0 times. So after that opening brace. Opening brace is also not considered, but according to the syntax, we have to represent opening and the corresponding closing brace. So this is the 0 times. Next, for I equal to 1 to n is repeated n plus 1 time. For example, n equal to 3. For I equal to 1, I less than or equal to 3, I plus plus. So initially n equal to 3, I less than or equal to n, I plus plus. First I equal to 1, 1 less than or equal to 3, condition true, hello printed 1 time. Next, again loop is repeated, I value is incremented, I becomes 2, 2 less than or equal to 3, hello printed second time. Again I value is incremented, I becomes 3, 3 less than or equal to 3, 3 times. Again I value is incremented, I becomes 4, 4 less than or equal to 3. For 4 value also we are going to verify the condition. So that means n equal to 3. Then we are going to execute the statement n plus 1 time. N plus 1 time. If it is n plus 1 time, the statements which are written inside the body is executed n times. That is the default one. If it is I equal to 1, I less than or equal to n, I plus plus, or for I equal to 1 to n is repeated n plus 1 time. If this statement is repeated n plus 1 time, the statements which are written inside the body is repeated n times. So this opening brace is 0 time, hello is n time. Then closing brace is also never executed by the compiler. So frequency count is 0. Again closing brace is also executed 0 time. N plus 1 and 2n plus 1. The total time complexity we are going to always consider the higher order. Then big O of n is the time complexity of the given statement. Let us look at one more example how to calculate the time complexity of an algorithm. So the first statement is repeated 0 times because we are not going to take any initialization. We are not taking any initialization. Second one is opening brace. How many times it is executed? 0 times. Sum equal to 0 I. That means how many times we can store? Only one time. Then I equal to 0, I less than n repeated n plus 1 time. If it is n plus 1 time, the statements which are written inside the body is executed n times, but we are storing an array. So for each variable of array takes 2n amount of time. Because it is an integer variable, 2n amount of time is to be taken. How many times we can return the value of sum? 1 time. The total time complexity is 1 plus n plus 1 plus 2n plus 1 plus 1. 2n plus 1, that is 3n plus 3. But we are always consider the time complexity in higher order. So higher order value is n. The total time complexity is big O of n. The total time complexity is big O of n. Then coming to the another example for addition of two matrices. The first one is the algorithm heading. By default, it is executed 0 times. Then opening brace. How many times it is executed? 0 times. Then after that, all the statements are written inside the body. These two statements are considered inside the body. I equal to 1, I less than or equal to m, I plus plus. That is a m. M is there. So this is executed m plus 1 time. If it is m plus 1 time, the statements are written inside the body is executed m times. This is executed m times. There are two statements are present inside the body. This is executed m times. Then after that, j equal to 1 to n is repeated how many times? M into n plus 1 time. If it is n plus 1 time, that what about the body of the statement? N times. So the default is if it is n plus 1 time, the first statement or first for loop is repeated n plus 1 time. The statements which are written inside the body is executed n times. That is the default one. M plus 1 plus m into n, mn plus m plus mn. How many times mn is present? 2mn, 2m plus 1. The total time complexity is big O of mn. Big O of mn is the time complexity for the addition of two matrices. So what is the default condition? If the loop is repeated n plus 1 time, the body of the statements which are written inside that loop is executed n times. Now coming to the space complexity. The space complexity. What is the definition of space complexity? The total amount of computer memory that is required to execute a particular statement is called as a time complexity. If you want to execute any program, first you have to store some values into the memory. So what variables you are going to take? What type of statements you are going to require the memory? We can store the instructions. C equal to A plus B is an instruction. For storing the instruction, constant values. A equal to 10 is the constant values. And also variable names. A, B, C or the variable names. We can use the variable names. For that also we can require the memory. And also like function calls. C equal to add of A comma B. It is a function call. Or go to. It is a jumping statement. For jumping statements, memory is required. Function calls, memory is required. For variables also, memory is required. Constant values, memory is required. Then for program instructions, memory is required. Based on all these things, we are going to calculate how much amount of memory is required. So the memory is represented in terms of bytes. Byte is the measurement for the memory. What is the definition of space complexity? How much of computer memory that is required for an algorithm to complete its execution is called as a space complexity. So generally we are going to use the computer memory for three reasons. First one is instruction space. Amount of memory that is required for the compiled versions of instruction. The statements which are to be compiled, for that only we have to allocate the memory space, that is called as a instruction space. Second one is the environmental stack. Environmental stack means amount of memory to store the information which are partially executed. For example, if you consider the function, that function is a partially executed, or this function is executed. How can you say that it is partially executed? Means while calling the function only that is executed. So if you don't call that function, it is never executed. That is the partially executed. We can arrange the environmental stack. Data space means the amount of memory for variables and constants. We can allocating the memory. Let us look at some example how to calculate the space complexity for the given pseudocode. Int square int a. So how many variables are there? 2 variables. So that only one variable. One variable, how much of memory is required? We are declaring only one variable. It is a variable. It is a variable. So in case of the new processor, that is 64-bit processor, integer takes 4 bytes, whereas 32-bit processor integer take 2 bytes. So for int a, 2 bytes. Assume that 2 bytes. How many times we can return the value? For return statement, it is also return integer value. A equal to 4. 4 into 4, 16. It's also integer value. 2 bytes. Total, how much amount of memory is required for executing this program is 4 bytes. If it is a 32-bit processor. If it is a that is a 16, that is a 8-bit processor. Okay, this is a 4-bit processor. Total for integer A, 4 bits of memory, and for return statement 4 bits. That means 8 bytes of memory is required for 64-bit processor, because it is a variable, and also return statements also some amount of memory is required. Which type of value it is returned? It is returns integer value. So total, if it is a 32-bit processor, 4 bytes of memory is required. If it is a 64-bit processor, 8 bytes of memory is required for executing this program. Let us look at one more example how to calculate the space complexity. Int sum, int a, int n. For these two variables, one is an array variable, another one is an integer variable. Integer variable, assume that it is a 32-bit processor. 2 bytes. For n, m is 5. 5 values are stored in an array. For each integer value takes 2 bytes. 5 into 2. 5 into 2. That means 2n. If it is n is 5, 10 bytes. If it is n equal to 3, 6 bytes. So 2n, then it is 2 bytes. 2n bytes. And then n bytes. For n bytes means 2 bytes. These two variables. Sum. That is a sum is an integer value, 2 bytes. For I also 2 bytes. So this is executed statements. Then after that, how many times we can return this value? 1 byte. So total, how much of memory is required? 2n plus 2, the sum 2 bytes, and for I 2 bytes. Then return statement for 2 bytes. Total 2n plus 8 bytes of memory is required. Total 2n plus 8 bytes of memory is required to store all these instructions. 2n plus n bytes are required to store all these instructions. So up to now what we have discussed, what is the metrics of performance analysis. Analysis means there are so many algorithms are there. Among all those, which is the best, we have to decide based on the performance metrics. There are 2 performance metrics are there. One is the time complexity, another one is the space complexity. Time complexity means how much amount of time is taken by the algorithm to execute a particular statement, or how much amount of computer memory is required to execute or to store the instruction. That is the space complexity. And also we discuss some examples based on the time and space complexity. Thank you.